So let's talk through. When you look at these word problems, what are the steps that you sort of have to go through? What's the first thing we always had to do? Okay, we needed to define the variables. Okay, so the first thing we need to do is to define variables. And what was our big clue for where to go to define the variables? The question. So you look at the question. So really it's going to be in question. Question usually comes at the beginning of the problem, at the end of the problem. Yeah, it's usually the end of the problem. So like you got a lot of stuff, a lot of numbers, your head is spinning, and then you get to a question, how many of each vehicle type, or how many of each whatever it is, supplement powder or War Eagle bakery or whatever. There's a question that tells you how to define the variables. You define the variables, and what's very important about when you define them? There are usually two of them. Sonia has it. Yeah, you'll pick two variables, but then what did I say for consistency you should always do? Yeah, make the first, so when you have your two variables, so typically you're going to have two variables, and then the first one is going to be your x-axis, and the second, make that your y-axis. And then every time you have an equation and you have those two variables, list them in the first and the second. If you ever mix them up, then when you go to substitute your answers, you might get confused. So be consistent about how you define them, okay? So after we get our variables, we had to use those variables to come up with what? An equation for a certain function. What is it? The objective function. So then you have to come up with the objective function. That is the function that you are trying to optimize. Okay, so it's an objective function, and I know that I'm using that to find the max or min. Okay, so my variables, my objective function, and then what did I have to go back? There was this table that I had to fill in. What was that for? Finding out the what? Constraints. Okay, then I have to get the constraints. And once I had the constraints, then I moved on to doing what? After you have all your variables, your objective function, your constraints, what do you do next? It's something you do visually. What is it? You had to graph. Okay. After that, you had to do a graph. The whole reason I do the graph is I need to figure out the what. Before I get the vertices, it's the, what's the name of that area that I'm looking for? Feasible region. So then you have to find the feasible region. Then once you have the feasible region, you look at that to determine the what? Vertices, okay? It starts to feel like it is in a flow at this point. Once I have the vertices, then I have to plug them into the objective function. So then I have to, find the max or min of each vertex. So there's no way to hide the fact that this is a lot of steps. Okay, I can't just say we're going to boil it down and we're going to do a one step. This takes several steps. It takes concentration. Part of the process here is to try to get you used to working a problem that takes more than 5 minutes. This one, what's it taking you? 10, 20, 30 to do one of these? 10, okay. 20, 30, it just depends. Some of them go a little bit quicker than others, okay? So this is where you can gripe. What are the challenges? What are the problems? What are the things that are sort of rough about this? Nothing? Come on, guys. Nothing? Come on. There's got to be something. I walked around and I didn't see them all done. There's got to be something there. Is it just how long they are? Is it define? Is it setting up? What's? Sometimes when you look at this, and I'm not there to work the problem. What is it that's like you're having? Like I'm not sure what to do. Finding intersections. Okay, graphing. What in what way? Like the line, or where to shade, or what?
I guess where to shade.
Okay. Okay. So the graphing. Okay. Yes.
Like finding the vertex that is not exact.
Yeah. Yeah. So finding the vertex, the one that happens to be at the intersection of two lines. Okay. And Saray had mentioned that on the calculator. You just need to be solid. The calculator can do that part. I would lean heavily on it for that. Okay. I mean, part of it is just like reading through the problem and extracting what numbers go where. Okay. Now, when you see this on a test, this problem is going to look. I mean, this is what it's going to look like on a test. Okay. You're going to have a problem, and then that problem is going to have a table here. Nothing's filled in. But I mean, this should be a good organizer for, okay, this sort of is a big clue. We need to start with our variables. We need to come up with the objective function. We need to determine constraints. So this chart sort of walks you through the process. Then you need to graph it and come up with the answer. So you're going to be not handheld, but you'll be guided a little bit. You're not just going to have a blank sheet of paper, okay? So you'll have things to do there. So let's take a look at another problem, and then stop me if there are things that you're not getting or need a different explanation. So the minimum daily requirements of a powdered dietary supplement are 1,200 units of vitamin A, 800 of vitamin B, and 1,000 units of vitamin C. An ounce of dietary powder X costs $3. Dietary powder Y costs $2. Use the table below. Find out how many ounces of each powder should be consumed to meet the cost and still meet the daily requirements. Okay. And this is funny. I say go to the question. There's a question mark, but grammatically that's not a question, is it? So here's the thing. Just what is it that it's telling me my variable should be here? Right. When it says how many ounces of each powder, that's telling me my variable should be the number of ounces of each powder. What are the two powders here? X and Y. Okay. So let's just start with that. So we're going to have X equal the ounces of powder X, and Y equal the ounces of powder Y. Okay. Now that's a good place to start. The minute I do that, then I know that this is X and this is Y. Okay. So I will always put X on the vertical. This would be confusing if you put Y on the vertical. Okay. So I've got that. Now, what am I being asked to optimize? Am I minimizing something or maximizing something? Minimizing what? The cost. I'm minimizing cost. So I'm going to have a function. So I'm asked to optimize. I'm asked to optimize the cost, and they're asking me to minimize the cost. Okay. So then I should be able to define the cost in terms of X and Y. Okay. So if you look at your problem, do I have a way of figuring out how much X and Y cost? X is $3, Y is $2. Okay, so this feeds into, this is X, what is it? X was $3 and Y is $2. So that's my cost function. Okay, that stuff should feel pretty straightforward, right? Okay. Then I move into the land of constraints. Okay. So now if you think about a dietary supplement, it says, and I'm trying to minimize the cost. Okay, so what do I need to do? Well, you've got vitamin supplements. Usually a vitamin supplement, when it has to meet a certain requirement, what kind of constraint is that? Like, it has to have what? I'm looking for words, at least, at most, what? At least. So like if this vitamin meets your requirements, you would say it has to have at least this amount of vitamin A. Okay? That's how it meets the requirement. So it might be able to have a little bit more, but if you said at most, it's not meeting a requirement. So these are going to be greater than constraints. So if you look at it, this tells me. So what are the constraints on this problem? In a broad category, it's got to have what? This supplement has to have what in it? Vitamin A, vitamin B, and vitamin C. This feels like how many constraints? 3 constraints. Okay, so I'm going to be constrained with vitamin A, B, and C. Okay, so in order for this powder to meet the requirements, it's going to have those 3 vitamins. So if you look at the chart real quick, I keep going back and forth. So vitamin A, it's got to have what, 500 units? So it's going to have 500. I'll let you tell me. And then vitamin Y, how much A? 400? I'm trusting you to agree with that. Okay, did I hear that wrong or did you tell me wrong? You're going to make me scroll up here every time. So vitamin A has 200, okay? Okay. And then what is my limit for vitamin A? I've got to have what? Yeah. So it tells me that vitamin A, I've got to have 1,200 units. So I've got to have at least 1,200 units of vitamin A. Okay. Then if I look at vitamin B, it's going to be 100, 200, and I got to have at least 800 units. So 1, 2, and 8. And then vitamin C, it looks like 100, 400, and what did it say? 1,000. 100, 400, and 1,000. Okay, does that appear to be right? Okay, so this is probably, in a number sense, this is a little bit harder, okay, decrypting all of this, but you should be able to read, once we've got the variables and the objective function, all the other numbers in the problem should be related to a constraint, okay? So now I'm pretty much ready to start graphing and doing my constraints. So my variables here are X. Remember that was the ounces of powder X. Y was the ounces of powder Y. My objective function was to minimize the cost. What was it, 3x plus 2y? Okay. And then I've got my constraints. So my constraints are 5, 2, and 12. So I had 500x plus 200y greater than or equal to 1200. And then I've got what, 1, 2, and 8. 100x plus 200y greater than or equal to 800. And the last one was 1, 4, and 1,000. Okay. Now, there are 2 constraints you don't want to miss because they're pretty easy. What are they? Yeah. The ounces of powder has to be a positive number. So x greater than or equal to 0, y greater than or equal to 0. Okay. These are all my constraints. Now I move into what? Graphing. Okay. Before I graph, I will always go find the x and y intercepts so I can graph this appropriately. Okay. If x is 0, then what does y have to be? 6, right? Okay. If y is 0, x has to be what? Yeah, it's 1,200 over 5, which is what? We can round that to a decimal. It's a 2.4. Okay. And now let's move on to the next line. I've got x and y. If x is 0, y is what? 4. If y is 0, x is 8. Okay. So even though these numbers look really big, the x and y intercepts are smaller numbers that are pretty manageable. Okay. X and y. If x is 0, y is 1,000 over 400. That's what, 10 fourths, which is 5 halves, which is, come on guys, this is called arithmetic. It's 2.5, okay? You can use your calculator for that. So 10 over 4 is 5 over 2, 2.5. If y is 0, what is x? 10, okay? Now, once I have all of these points, I need to scale my axis so I can draw this. The last thing you want is to try to draw this and it's too scrunched up. So my x values need to go from 0 to where? 0 to 10. Okay, this is a good grid for that. So what is I can do? 1, 2, I can do, is this 20? 1, 2, 3, 4, 5. Yeah, so each one can be, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. My y-axis needs to scale from where? 0 to 6. So I could, if I scaled it the same, 6 is going to be right here. So I'm doing a pretty good job of taking up. So I'm just going to scale this the same. So 1, 2, 3, 4, 5, 6, 7, 8. There we go. Okay. Now I just have to plot these lines. This one with 3 constraints. You see the color is going to be pretty helpful. 0, 6. That's right here. And 2.40. So 2.40 is going to be about right there. And then I have to draw that line. There are rulers here if you guys need them. So, or you can use some kind of straight edge. Okay. Now the blue line goes through 0, 4 and 8, 0. And the green line goes through 0, 2.5, and 10, 0, which is right here. Okay. Now this one looks a little more complicated, right?
I think it's easier though.
Okay. Now, where do I shade? Above which ones? All of them. So you should see if I'm shading above every line, that means I'm above this line. I'm above the blue line. I'm above the red line. So this is my area all right here, okay? So that's my feasible region, is all of that. Now, where are the vertices? There's one right there. There's one right there. There's one right there. And there's one right there, okay? So you look at all the vertices of that region. Okay, 2 of them are really easy. 2 of them are going to require a little bit of work. What's this first one here? 0, 6. And what's this one over here? 10, 0. Okay. Do you see why this is not a vertex right here? Okay, I had to shade above every line. This is above the green and red line, but it's not above the blue line. So it has to be above every single line that is there. The only way I can be above the green, the blue, and the red is what I have here in yellow. This is the only area that's above all 3 lines.
So wait, how is 10 0?
Well, it's right here. This is above the green line. Okay. So the vertices that you care about are the ones that touch this feasible region. So there are 4 of them. Okay? So I need to find where do the red and blue lines intersect. What does it look like? It looks like maybe 3.5, something like that. But that's not a guess I'm willing to take. Okay? So let's find where the red and the blue lines intersect. Okay? So that's going to be, let me just write this. I got what, 500x plus 200y, 1200, 100x plus 200y, 800, and 100x plus 400y, 1000. So that's the red, the blue, and the green. So where do the red and the blue line intersect? That's where I said the easiest thing to do is going to be use your calculator and menu, algebra, solve system of linear equations, 2 variables, x and y. And here I just put in these 2 equations. 500x plus 200y equal 1200. And then tab, the next one was 100x plus 200y equal 800. And I get 1 7/2, or 1 3.5. Is that what you were talking about, Saray, that you weren't quite sure about? Was there a question? All 3 of them? Well, because this is not where all 3 lines meet. This is only where the red and the blue line meet. And this is why the color is helpful, because once you've drawn them and they're all the same color, you're like, oh my gosh, which is which? Okay? So I can see where does the red line and the blue line meet, and I look at, here's all my stuff in red, here's all my stuff in blue. So I don't have to wonder, does this correspond to this one or which one? So that's why I use different colors. Yes? Well, once I have the feasible region, it's all of the points that are there. Okay, so all the points that touch the feasible region.
What about the red and... Oh, never mind.
Okay, so I've got this point is what? This is 0, 6. We just determined this to be 1 7/2, or 1 3.5. This point is 10, 0. And then how do I figure out that next point there? It looks like maybe it's 6, 1. I'm not sure. What do I do? It's where what? Where the green and the blue line intersect. Okay? So I'm going to go to my calculator.
So
and
if it's like on a corner like that, the point yourself, maybe use a calculator.
Like here?
Yes.
Now you know that point is 10, 0.
Like on like
Yeah.
where you can see it, like you can see it's at 6.1, but it's at just.
Well, okay, I'm guessing my graph tells me that I think it's 6, 1. But what if it's 5.5, 1, and my graph is not right? So that's what I'm not willing to take that gamble when I've got a calculator in front of me that can solve it pretty quickly. So algebra, solve system 2, x and y. So I've got these 2 lines. So it can be 100x plus 200y equal 800. And the next one is 1, 4, and 1,000. So 100x plus 400y equal 1,000. And it is 6, 1. Okay? So that is the point 6, 1. Okay, a lot of work, but now I have 4 vertices. What do I do with them? Yeah, I've got the vertices and the objective function. So it was cost equal, what was it, 3x plus 2y? So I've got to figure out what the cost is at 0, 6, at 10, 0, at 1, 3.5, and at 6, 1. Okay? So this is going to be 3 times 0 plus 6 times 2, which is 12. This one is 3 times 10 plus 2 times 0, which is 30. The next one is 3 times 1 plus 2 times 3.5. What's 2 times 3.5? 7. 7 plus 3 is 10. Okay. And the next one is going to be 3 times 6 plus 2 times 1. That's 18 plus 2, which is 20. What was my goal in this problem? Minimize. So where's the minimum? Yeah. Now, do you just leave those numbers and hope you got it right? No, you've got to answer this. What was the original question? Let's just always go back at this point. How many ounces of each powder should be consumed each day to minimize the cost and still meet the minimum daily requirements? Now here they did not ask me the minimum cost, okay? But they could have, and probably on the test it will. So I would just go ahead and be prepared to say that. So I should do what? 1 ounce of X and what? 3.5 ounces of Y for a minimum cost of what? $10. Okay.
Why
So
do we choose that one? Oh, we never mind.
it's the smallest number of all of these. Okay. So the problem we did yesterday was maximization. What's the big difference in minimization?
Biggest, smallest number.
Yeah, I mean, when everything was the same except when I got to the end, I'm looking for the smallest number. Okay, so really there's not a substantial difference, okay, in what we need to do. Let me just pause this for a second. And like I said, guys, there's going to be no substitute for you spending time with these and just seeing how can you decode it. You know, they probably look easier when I'm doing it than when you're looking at it on your own. So talk me through this, okay? Woodward has contracted with the rock group U3 to perform at school. The gym can accommodate at most 1,000 people. The school has guaranteed the ticket receipts would be at least $4,800. Tickets are $4 for students, $6 for non-students. U3 would be paid a fee of $250 for each student ticket, $450 for each non-student. What is the minimum pay for U3, and how many of each ticket type must be sold instead of most for this minimum payoff? So I go straight to the question, okay, and that tells me what my variables. What are my variables going to represent? So what are they asking me to find?
The minimum amount of pay they get.
Minimum pay. That doesn't tell me my variable. That's what I'm trying to optimize. Which of those, what part of that question tells me what my variables are?
How many of each type of ticket?
Each type of ticket. How many of each type of ticket must be sold? Then I go back, well, how many types of tickets are there?
4.
Let's go with 2. What are the 2 types of tickets? Student and non-student. So what are the variables going to be? Yeah, student and non-student. Okay, what do you want to call them? S and N. Okay, so let's do that. So my variables are S equal the number of student and N equal the number of non-student. Okay, the minute I do that, it didn't matter. You could have done N and S, it did not matter. But because I did S and N, I'm going to be very consistent. This is my S axis right here, and this is my N axis. Okay, and then when I go to define my objective function, what am I trying to minimize here? I'm trying to minimize the payoff. So I'm going to say payoff equal, it's going to have something S and something N. Okay, so every time I have these variables, you're going to see S first and N second. Okay, what's the payoff on a student ticket? How about 250? The payoff is 250 for each student ticket, right?
Is the fee like how much U3 will get?
Right.
250 out of each $4?
Yeah. And then 450 for non-students. Okay, so that's the payout. Okay. Now I go to my constraints. Okay, so when I look at this chart, I'm always consistent. This is going to be S. This is going to be N. Over here, there's some kind of limit. Okay, that's what I'm looking for. Okay. Now, what are the kinds of constraints that are there? The gym capacity. So gym capacity was 1. And what else? Yeah, we've guaranteed that the receipts, the money we take in, so the ticket receipt, and that should be it. So gym capacity. What is the capacity of gym? Yeah, the word's at most. So when I say at most, that means it's going to be 1,000 or what? Less. So that means what kind of sign goes here? Yeah, less than or equal to 1,000. Okay. The receipts I've said would be what? At least 4,800. That means 4,800 is as small as it can be. So it's okay to be bigger. Okay. So how do I handle this constraint? The capacity is 1,000. It's what? S and N, right? The number of students and the number of non-students are going to have to be less than or equal to 1,000. And then the 4,800, how do I handle this one? Yeah, so it tells me that $4 for every student ticket, okay, and $6 for every non-student, and that has to come up to be 4,800 or more. So now I'm ready to start graphing. So the constraints that you do not want to miss are what? S and N are both greater than or equal to 0. Okay. I mean, you don't want to lose half a point or whatever just for skipping that one. Okay. So then I'm going to have S plus N is less than or equal to 1,000. And 4S plus 6N is greater than or equal to 4,800. And before I graph it, let me just find my intercepts, S and N. If S is 0, what is N? 1,000. This one's pretty easy, okay? And then over here, if S is 0, what is N? 800. And if N is 0, what is S? It's, is it 4 times 12? Yeah, so 1,200. Okay. Now, my S-axis needs to scale from where? From 0 to what? 1,200. And my N-axis needs to go from 0 to 1,000. So if I get over by 12, so I could do, this is what, I could do something like 2, 4, I could do that. So this is maybe 200, 400, every other one, 600, 800, that's 1,000. And this one is 1,200. Where do I need to go? 1,200, okay. So this was 1,000 right here, that was 1,200. So I counted every 2. And then I'll probably scale the same thing. I need to go up to 1,000. So I'm going to write this is 200, 400, 600, 800, 1,000. Okay. So I need to find the point 0, 1,000 with 1,000, 0, which is right here. Draw a line. Okay, and then the green line is going from 0,800 to 1,200, which is right here. Okay, where am I shading? Relative to the red line is what? Below the red line and what? Above the green line. So where do you see that? Yeah, it's this area right here. Okay. Below the red and above the green. Okay. I might could have benefited from spreading this out. You can see that. So, but there we go. So, does everyone see why that is? Above one, so it's below the red line, above the green line. How many vertices are there? 3. So before I figure out what they are, I know that there are 3 choices. Okay. So it looks like my vertices are 0,800 and 0,000. And what does this point look like? It looks like what, 600, 400? Okay. Now I got a choice. I can just plug that in. So if it's 600, 400, does 600, 400 satisfy this equation? 600 plus 400 is 1,000. What about here? 600, 4 times 6 is what, 2,400, plus 2,400 is 4,800. So it works. Now, but if I don't want to do that, if I always want to just do my calculator, I can go to the calculator and verify that. So I know that that other point was 600, 400. And then what do I do now? I have to test the objective function, which was what? So 2.5s plus, what was it, 4.5n? Was that it? Okay. So the cost, I got to figure out the cost at 0,800, the cost at 0,1,000, and the cost at 600, 400. So this is going to be 0 plus 4.5 times 800. It's 3,600. The next one is going to be 0 plus 4.5 times 1,000, which is going to be what, 4,500. And then the last one is going to be 2.5 times 600 plus 4.5 times 400. And that is what, 3,300. So which of these represents the minimum payout? Minimum. Huh? None of those are a minimum? Well, it tells me that not the payout, the receipts are 4,800. That's the ticket receipts. Okay? That's not the payout. The payout is this is the minimum payout. Which of these is the smallest number? This one, right? Yeah. So that's it, okay? So that tells me, what was the question then? What's the original question?
What was the minimum payout?
Minimum payout. The minimum payout is 3,300. So the minimum payout is 3,300. Did it ask for the ticket types?
Yes.
Come on. What did it ask? You know, how many of each ticket? Where do you get that from? So it's 600 students and 400 non-students. Okay, that's the answer. Okay.